70 to 100 kilometers of the Cotabato Trench have not ruptured since 1918, when that stretch of fault produced a magnitude 8.3. A strong earthquake struck the southern Philippines yesterday, and the first thing seismologists did was check whether it happened there. It did not. It broke at the far end of the zone on a different structure, releasing about 1/150th of the energy of the quake that killed 100 people in June. By the end of this, you will know the one signal scientists are watching for now. Yesterday at 12:14 in the afternoon Philippine Standard Time, a strong earthquake struck offshore in the southern Philippines, off the southern tip of Mindanao. Within minutes, the Philippine Institute of Volcanology and Seismology, 5-ALCS, pushed out its first bulletin. That bulletin put the magnitude at 7.0, and it placed the epicenter roughly 258 kilometers, about 160 miles, south-southeast of Sarangani, near the Talaud Islands. That position is effectively inside Indonesian waters. Then, the solution changed. As more seismic stations reported and human analysts reviewed the data, 5-ALCS published earthquake information number 2, and the numbers in it were substantially different. Magnitude 6.4, depth 13 kilometers, about 8 miles, epicenter 37 kilometers, roughly 23 miles, southwest of Bulletin Island in the municipality of Sarangani, province of Davao Occidental. Tectonic in origin. Intensity 5, strong shaking, reported in the town of Glan. The United States Geological Survey landed slightly differently again. Magnitude 6.3, depth 10 kilometers or about 6 miles, epicenter roughly 32 kilometers southwest of Sarangani. Green alert. Tsunami flag set to 0. The European Mediterranean Seismological Center matched the magnitude at 6.3, but put the depth at 35 kilometers, which is a routine early solution discrepancy in this part of the world. Stack those two bulletins next to each other, and you get the number that made this event strange before it made it interesting. The epicenter moved 258 kilometers on review. The magnitude dropped by 7/10 of a unit. Both of those revisions are unusually large, and both of them matter, because the story you tell about this earthquake depends entirely on which set of numbers you believe. Under the first bulletin, this was a magnitude 7 near the Talaud Islands, a new rupture on a different stretch of plate boundary. Under the reviewed solution, it is a moderate event sitting inside a sequence that has been grinding on since June. Same seismogram. Two completely different stories. There is a second source of confusion in this event, and it is not seismological at all. It is geographic, and it has tripped up nearly every headline written about the southern Philippines this summer. There are two places named Sarangani in southern Mindanao. The first is Sarangani the province, sitting next to General Santos City in the region known as So-Si-Sisk-Sargan. That province is where the destruction from the June 8th earthquake was concentrated. Glan, the town that reported the strongest shaking yesterday, is in that province. The second Sarangani is an island municipality in the province of Davao Occidental, considerably further south. It is made up of Bulletin Island and Sarangani Island, and yesterday's epicenter sits about 37 kilometers southwest of Bulletin. The two Saranganis are separated by roughly 100 kilometers, about 62 miles. Same name, different administrative units, different distance from the June rupture zone. So when you see a headline in June reading "Earthquake hits Sarangani," and another headline in August reading "Earthquake hits Sarangani," those two headlines are not describing the same place. That distinction is going to matter enormously in a few minutes, because the entire question of what this earthquake means comes down to exactly where it happened, relative to a stretch of fault that has not moved in more than a century. 5-ALCS logged intensity 5, strong shaking, in Glan, intensity 4, moderately strong, in Cayamba and in General Santos City, intensity 3 in Masim, Malapatan, Sarangani, and Lake Cebu, intensity 2 in Banga and Surala in South Cotabato. The USGS estimated a maximum of modified Mercalli 6, which is the level at which everyone in the affected area feels the shaking. Objects come off shelves and poorly constructed buildings can sustain damage. Well-engineered structures generally ride it out. The exposure numbers from the USGS rapid assessment system fill in the human scale. Roughly 15,000 people experienced strong shaking. About 88,000 felt moderate shaking. Around 5.4 million felt light shaking, and another 600,000 felt it weakly. The nearest population center to the epicenter is the island municipality itself, with about 7,500 residents. Glan, 72 kilometers to the north, has around 24,000. Coronadal, 155 kilometers away, has nearly 200,000. It is worth pausing on what those intensity numbers actually describe, because the scale is not a measure of the earthquake. It is a measure of the experience, Magnitude is a single number for the whole event, computed from the energy radiated at the source. Intensity is local, and it changes from town to town depending on distance, on the direction the rupture propagated, and above all, on what is under your feet. Soft sediment and reclaimed ground amplify shaking. Hard bedrock does not. 2 towns. The same distance from the same epicenter can report intensity 3 and intensity 5, and both readings can be correct. That is why Glan, 72 kilometers away, logged stronger shaking than several places closer to the epicenter. The USGS assessment of the building stock in this region is worth quoting closely because it is the part that does not make it into most coverage. The agency notes that the population resides in structures that are a mix of vulnerable and earthquake-resistant construction, and that recent earthquakes in this area have caused secondary hazards, such as landslides, that may have contributed to losses. Green alert means low probability of significant casualties or economic damage. It does not mean nothing happened, and as we will get to shortly, there's a specific reason that assessment may be optimistic in this particular corridor right now. Here is where the story stops being about a bulletin correction and starts being about geology. When seismologists want to know what actually broke, they compute what is called a moment-tensor, a mathematical description of the forces at the source, derived from the shape of the seismic waves the event radiated in every direction. And the moment-tensor for yesterday's earthquake came back about as clean as these things get. 92% double couple. In plain terms, that number tells you how well the recorded waveforms match the pattern you would expect from one block of rock sliding past another along a single flat fault surface. 92% is high. It means there's essentially no volcanic component in the signal, no fluid injection signature, no mechanical ambiguity for anyone to argue about. This was rock sliding on rock. The geometry is equally specific. The W-phase solution gives a magnitude of 6.35 at a depth of 11.5 kilometers, with a half duration of 3.5 seconds. Both possible fault planes dip near 90 degrees, approximately 80 degrees and 96 degrees, which makes this pure dip-slip reverse motion. That is thrust faulting, one side of the fault being shoved up and over the other. The compression axis points at 255 degrees, meaning the maximum squeeze on this piece of crust runs roughly east-northeast to west-southwest. Both fault planes strike north-northwest to south-southeast, running parallel to the trench in that segment. Every one of those numbers points the same direction. 255 degrees is precisely the convergence direction you expect, where the floor of the Celeb Sea is being driven eastward beneath Mindanao. The trench parallel strike matches. This is a subduction thrust event, and the data does not leave much room for a second opinion. Now take the depth and put it next to the earthquake this sequence started with, because that comparison is the single most consequential piece of information in this entire story. The moment-tensor puts yesterday's rupture at 11.5 kilometers, about 7 miles below the seafloor. The June 8th magnitude 7.8, the main shock, the event that killed more than 100 people, was placed at roughly 33 kilometers by FIVOLX and at 55 to 57 kilometers by the USGS. That is not a small difference. Yesterday's earthquake sits far up dip of the patch that broke in June, meaning much closer to the trench, much shallower, well above the depth range where the main shock rupture lived, which tells you something the word aftershock completely obscures. This was not the June 8th fault surface failing again. It was a different structure. There are 2 candidates that fit. The first is the shallow, near trench portion of the subduction interface itself, the part of the megathrust closest to the trench axis, sitting above and seaward of the patch that ruptured in June. The second is a splay thrust in the accretionary wedge, one of those secondary faults that branch upward off the main interface through the pile of scraped-off sediment stacked against the edge of the overriding plate. The accretionary wedge is worth a moment because it is the part of a subduction zone most people have never heard of, and it does a disproportionate amount of the damage. As one plate slides beneath another, the sediment sitting on top of the descending slab gets scraped off, the way a bulldozer blade peels material off a road. That scraped material piles up into a wedge against the front edge of the upper plate. It is weak, water-saturated, and shot through with faults that branch off the main plate interface and angle up toward the seafloor. When one of those splay faults moves, it moves shallow rock very close to the ocean floor, which is precisely the geometry that lifts water. The wedge is where a moderate earthquake can behave like a much larger one. Both possibilities are consistent with stress transfer from June 8th. Both mean the same thing. A different part of the same system failed, rather than the same part failing twice. And that distinction is not academic. A stress transfer failure on a neighboring structure is exactly the mechanism by which large earthquakes propagate along a plate boundary over months and years. It is not the mechanism by which a sequence quietly winds down. There is one more thing the mechanism tells us. The June 8th main shock has never been definitively attributed to a specific fault. The two candidates have been the Sangihei Trench to the south and the Cotabato Trench to the north, and that question has stayed formally open since June. The Sangihei side dips west. Yesterday's solution is east-dipping. That argues for the Cotabato Trench, which means a moderate earthquake nobody expected to be important, just contributed a real piece of evidence to a question seismologists have been unable to close for 2 months. And for the record, the two other well-known structures crossing Mindanao, the Mindanao Fault and the Philippine Fault, are both left lateral strike-slip systems lying well to the north-northeast. Neither is a candidate here. A strike-slip fault does not produce a thrust mechanism. The main shock did not arrive alone, and the way its aftershocks behaved is its own piece of evidence. Over the 5 hours and 3 minutes that followed, the international catalogs logged 8 more earthquakes of magnitude 4.6 or greater, plus a 9th recorded by the Philippine National Network but not by the global feed. At 4:25 UTC, a magnitude 5.2, 31 kilometers south of Sarangani. At 4:34, a magnitude 4.8, 64 kilometers southwest. At 5:13, a 4.9, 45 kilometers southwest. At 5:53, a 4.6, but this one 84 kilometers to the east-southeast. At 5:57, a 4.9, 54 kilometers east-southeast. 2 minutes later, at 5:59, a magnitude 5.1 back at 46 kilometers south-southwest. Around 6:41, the Philippine network caught a magnitude 5.0 at 17 kilometers depth. And at 9:17, a 4.8 back in the southwest cluster. Read that sequence carefully, and you notice something that does not match the textbook. Aftershocks are supposed to cluster tightly around the rupture and decay outward. This sequence starts southwest of Sarangani, then jumps roughly 130 kilometers to the east-southeast, then comes right back to the southwest within 2 minutes. The activity is spread across a zone spanning something like 130 to 150 kilometers, rather than concentrating on a single point source. That does not, on its own, mean anything alarming. A magnitude 7.8 rupture loads a very large volume of crust, and a broad aftershock distribution is a normal consequence of that. But it is the kind of observation that seismologists mark down and keep watching, because spatial behavior is precisely the variable that carries the warning signal in this situation, and we will come back to that. 12 minutes after the shaking, at 4:26 UTC, the National Oceanic and Atmospheric Administration published a tsunami bulletin for Mindanao. The bulletin as issued carries no warning status and no impact details. The USGS tsunami flag for the event reads 0. International reporting on the day stated correctly that no tsunami warning was triggered. The more accurate way to describe what happened is that the warning system evaluated the event and issued a no-threat product. It fired, it ran the numbers, and it stood down. That is the system working. But it is worth understanding why it fired at all, because the answer is one of the more uncomfortable pieces of physics in subduction zone science. Shallow thrust earthquakes close to the trench axis generate tsunamis out of proportion to their magnitude. They displace the seafloor across a large area through low rigidity rock, and they frequently rupture slowly, which produces more seafloor uplift per unit of radiated seismic energy than a similar-sized event further down the fault. A shallow, near-trench thrust punches above its weight in water displacement. At magnitude 6.3 to 6.4, that is not a practical concern and nothing happened. But the initial bulletin said 7.0 at exactly this geometry, and that is why the evaluation ran. Take the same fault, the same depth, the same mechanism, and add 1 magnitude unit, and the conversation becomes entirely different. For a sense of the scale involved, the June 8th magnitude 7.8 produced confirmed waves of roughly 1 to 1.4 meters, 3 to 4.5 feet, across 6 coastal areas of Sultan Kudarat and Sarangani. Waves at or below 1 meter are lethal. They knock people off their feet, sweep them into debris fields, and pin them against structures. And it gets worse when you look at what has not moved. Before we go there, one thing circulating online needs answering, because the numbers I just walked through make it easy to answer. The claim is that the agencies are concealing the real magnitude, that 5 published a 7.0, then quietly walked it back to a 6.4, and moved the epicenter 160 miles when nobody was looking. Watched in real time, that does look like a cover-up. The reality is that automatic solutions are computed from the earliest arrivals at whichever stations report fastest. For an offshore earthquake with all the land stations on one side and open ocean on the other, the azimuthal gap is enormous, and the location is poorly constrained along one axis. The algorithm will cheerfully place the event hundreds of kilometers along that axis. That is a known failure mode, and it is exactly why the bulletin was stamped automatic. The reviewed solution used more stations, a longer time window, human analysts, and a W-phase moment tensor, which is a fundamentally more robust way to measure magnitude than early amplitude methods that saturate on large arrivals. The revision trail, information. Number 1, then number 2, is the transparency, not the concealment. The companion claim, that something artificial triggered this quake, dies on the same table, that 92% double couple is the answer. An explosion produces a large isotropic volume change component. A fluid-driven or volcanic source produces a significant compensated linear vector dipole component. Yesterday's event has neither, and its compression axis points exactly where plate convergence says it should. Now the part that actually matters, and the reason seismologists spent yesterday afternoon looking at a map rather than a magnitude. Analysis. After the June 8th main shock identified a section of the Cotabato Trench roughly 70 to 100 kilometers long, 43 to 62 miles, that has not ruptured since at least the 1950s, and most likely not since 1918. The 1918 event on the system was a magnitude 8.3. That is the demonstrated capability of this structure, not a model output, not an extrapolation. A recorded event. The reason a seismic gap like that draws attention has a name, and the name is static stress transfer. When a large rupture happens, it does two things at once. It unloads the stress on the patch of fault that actually slipped, and it increases stress on the rock surrounding that patch, particularly along the fault line beyond each end of the rupture and above and below the slipped area. Modeling of these stress changes routinely finds increases of a few tenths of a bar to a few bar in those lobes. That sounds like nothing, and in absolute terms it nearly is. But on a fault that has already spent a century loading toward failure, a small nudge is enough to advance the clock. Yesterday's earthquake, sitting up dip of the June rupture with a thrust mechanism aligned to regional convergence, is a textbook expression of exactly that geometry. A neighboring structure failing because June 8th changed the stress on it. The geometry of that gap is what makes it hard to look away from. It sits between the June 2026 rupture on one side and the rupture area of a magnitude of 7.5 from 2023 on the other. Two major earthquakes have gone off on either end of it within the last 3 years. The segment in between has released nothing. Now put yesterday's earthquake on that map. The gap is to the north. Yesterday's rupture was at the southern end of the aftershock zone. Whatever happened yesterday, it did not happen on the segment that has scientists concerned. The loaded piece is still sitting exactly where it was, unmoved. And here is the arithmetic that closes the door on the most common misreading of this event. A great many people hear magnitude 6.4 and conclude that pressure got released, so the danger went down. Yesterday's earthquake released approximately 1/150th of the energy of the June 8th main shock, against a plate boundary that has been converging at roughly 7.3 centimeters per year since at least 1918, 108 years of accumulated slip deficit, which on a locked segment adds up to something measured in meters. A magnitude 6.4 consumes essentially none of it. Nothing meaningful was drained yesterday. To understand how unusual any of this is, you have to understand what the June 8th earthquake did. The main shock struck at 23:37 UTC on June 7th, early morning local time on June 8th, offshore of Sarangani province and General Santos City. Final magnitude 7.8, though an early automated solution briefly ran as high as 8.2, maximum intensity 8. It was the strongest earthquake to hit the Philippines since the 1976 Moro Gulf disaster. As of the July 21st accounting, the toll stood at least 106 dead, 1,316 injured, 7 still missing, and more than 121,300 homes damaged or destroyed. The figures reported in the first 48 hours ran far lower, 32 to 45 dead, because that is what a 24-hour count looks like before the assessments come in. Since then, Five Oaks has recorded more than 8,500 aftershocks, 3 of them above magnitude 6. The largest so far is around 6.5. There is a statistical rule for this, called Both's Law, which says the largest aftershock in a sequence typically falls about 1.1 to 1.2 magnitude units below the main shock. For a 7.8, that predicts the largest aftershock, somewhere around 6.6 or 6.7. 6.5 sits just inside that expectation. Yesterday's event was the 4th magnitude 6 or greater earthquake in the sequence, and the second in 3 weeks. A 6.5 on June 26th, a 6.2 on July 14th, with an epicenter about 19 kilometers from yesterday's, and a 5.1 near Balut Island on August 1st. None of that is abnormal for this plate boundary. 17 earthquakes of magnitude 6.5 or larger have struck this region in the past decade alone, 7 of them above magnitude 7. This is one of the most seismically active margins on Earth, and yesterday's event, taken by itself, is ordinary here. What is not ordinary is the condition of the buildings underneath it. Fivolks stated no damage is expected from yesterday's shaking, and that assessment is calibrated against structurally sound construction. Across the corridor that June 8th wrecked, masonry is already cracked and weakened, and 121,000 homes are already damaged. A magnitude 6.4 shaking intact walls and a magnitude 6.4 shaking walls that have been holding on since June are not the same event. So where does this leave us? Yesterday's earthquake was not dangerous on its own, and it was not the scenario anybody is worried about. Its value is diagnostic. It told us that the crust beneath southern Mindanao is still adjusting 2 months after a magnitude 7.8, that the structure failing now sits up dip of the June patch rather than on it, that the responsible fault is very probably the Cotabato Trench rather than the Sangihei, and that the segment with 108 years of stored strain on it did not move. The observation that would change the picture is not a bigger number. It is a direction. If aftershock activity keeps decaying the way Omori's law says it should, rate falling off roughly in inverse proportion to time since the main shock, then this sequence is doing what sequences do. But if the clusters of magnitude 4 and magnitude 5 events start stepping progressively north toward that unruptured stretch of the Cotabato Trench, that is a different observation entirely, and it requires no new science to spot. It only requires watching where the dots land on the map. 2 other things are worth tracking over the coming days. The first is damage reporting out of Glen and the June-affected corridor over the next 24 hours, which is a concrete, checkable test of whether intensity 5 shaking into already compromised masonry produces reported losses that the green alert did not anticipate. The second is whether the east dipping mechanism from yesterday shifts the published attribution of the June 8th main shock toward the Cotabato Trench in the coming assessments, which would close a question that has been open since the day it happened. Nobody can time the gap. Earthquake prediction remains impossible, foreshocks are only identifiable in hindsight, and the segment could release in a decade or in a century. Anyone claiming otherwise is selling something. But the honest version of the situation is more unsettling than any theory about hidden data. The loaded piece of the Cotabato Trench is publicly documented, openly discussed, and completely untimable. It did not move yesterday, that is the whole finding, and it is worth checking the map again in a week.